All right, line Q1, learning task 3. This is a B video, meaning we've got a long topic that just, takes a while to get through. So we went through the first part of our learning task. We covered off a whole pile of components, and now we are up to the point where we're going to start talking about raceways and about the wiring itself that we're going to go and have inside of there. Different types of conductors, etc. Some of it's going to be repetitious of what we have had before. We'll just kind of skip past those ones. Anything new, we will go and make sure that we specify as being new inside of there. Let's start inside of our Canadian Electrical Code over here again. Once again, going back into our section number 12, we know that 12 is broken down into a number of different components. Starting over at 12-100, we go and take a look at conductors. And it's going to be just a bunch of stuff to do with different types of conductors. Lumex, BX, tech cables, mineral insulated. All of those are going to be found inside of there. So there's a bunch of cable rules first that talk with spacings and things like that. And then when we move further into there, we get 12-900, which is going to be our second section, which deals with our types of raceways. Different types of raceways are all going to be laid out inside of there. Once again, rigid and flexible metal conduit, rigid PVC conduit, DB2 type of conduit. They have inside of there, by the way, and we'll just go take a look at this. What I want you to do in yours is go and highlight just that DB2, because sometimes I find that students will go and try to answer questions to do with rigid PVC out of here because they just see that word PVC. DB2 is a type of thin wall PVC conduit. Just make sure you've got that listed there as being DB2. That's going to be that thin orange or that thin gray that we use usually for communication circuits, and it's going to be completely different than the thick light gray, the rigid PVC that we use for wet type of locations. We've got a couple of other ones inside there as well. RTRC is rigid reinforced thermoset rigid conduit. It is a type of thermosetting, meaning it gets harder with heat, fiberglass conduit. We'll use these things inside of specialized applications where we need something harder than PVC, generally hazardous types of locations. HDPE, which is high density polyethylene. This is a new one. It's very similar to my irrigation line, if you've ever seen it. It's like that black plastic. It can come on a giant roll, which makes it really handy for doing things like parking lot lighting and stuff. Instead of having to glue together, a ton of different pieces, what you can do is you can have just one big roll, and you can just roll from lamp standard to lamp standard, etc., and then just pull your conductors in afterwards. It does have a bunch of rules. Particularly, it's going to be restricted to being underground for absolutely all the length or installed inside of concrete. You can't just run it on the surface or anything like that. We've got liquid tight flexible conduit. That's what we normally just refer to as liquid tight. And this could be the plastic or it could be the metal type of liquid tight. Both of those fall underneath this one. We have got EMT. What we refer to as conduit is actually EMT. It's electrical metallic tubing that we are going to have. There's rules. Then we have got ENMT, electrical non-metallic tubing. This is what we generally refer to as being core line. It's not anywhere in the code that you will find the term core line, even though we use that to describe that type of conductor that we generally put inside of slab. Has to always go and stay, inside or underground, etc. Surface raceways, those are going to be things like wire molds, panduit, stuff that is going to be usually ornamental. It's, kind of a last-ditch effort for when you got to bring wiring around some place where it was never really allowed for. Underfloor raceways that we are going to have that are specialized types, used generally for like data, things like that. Cellular floors, where we have got sections of floor that can be used as raceway, auxiliary gutters, busway splitters, wireways, etc. There's a bunch of different types that are going to be laid out inside of there. Once again, if you're looking for rules specific to any one of them, you need to first identify what it is you're looking for. If you're looking for core line, go and take a look at the electrical non-metallic tubing rules that you're going to have. Open wiring. They have a little brief explanation on open wiring in here, even though they don't do a lot of the other ones inside of this this book over here. But the open wiring, I'll just go back to that one there. I jumped too far ahead somehow. Open wiring was an older style where we would go and have insulators. We would run conductor from conductor inside of those. We sometimes still hear about knob and tube inside of houses. That is a form of open wiring. And these days, usually we only see it now for photovoltaics because those are going to be single cables, a hot or a negative that we are going to have for photovoltaics, but they do need to be run as open wiring inside of there. There's a bunch of rules on spacing and supporting, etc. Support is always going to go and be laid out inside of our code. We need to go and make sure that every single conductor is going to be supported properly. So 12.120 talks about supporting the conductors, and then inside of my raceways, we're going to have individual rules for supporting our races. Obviously, some stuff like rigid metal conduit does not need to be supported nearly as often as other things like, floppy liquid tight or anything like that. So those are going to have different ones. 12.120 over here starts out by saying that, first of all, conductors have to be supported so that there is no damaging strain imposed on the terminals of any electrical apparatus, devices, or on joints or on tabs. So you've got to support the cable so that the actual connection is not, pulled taut or anything like that. Vertical raceways, if we're going up a shaft in a building, you got a multi-story place, you need to make sure that there's going to be vertical supports as well. And for types of armored cable, TEC, RA, RC, AC, and ACWU, you need to make sure that the internal conductors inside of that also are not going to slip down in there. Individually, different types of conductors are obviously going to need to have different types of supporting that we are going to go and have. This is not laid out inside of this rule, 12.120. That's going to be my general, that fact that every conductor needs to be supported, etc. If I wanted to find for my Lumex, I would go directly to the Lumex ones over here. And then it talks about how I need to go and run them, continuous, etc. And then it talks about, keeping them away from sources of heat, things like that. Can't staple it on an edge. And then down here, I go to running a cable between boxes. This is where we find our supports for Looming. So it says that where the cable is run between boxes and fittings has to be supported by straps, type 2S or 21S cable ties, those are tie wraps that we call, or other devices that are going to be located within 300 millimeters, that is 1 foot of every box, and at intervals of not more than 1.5 meters throughout the run. 1.5 meters being 5 feet, and 300 millimeters being 1 foot. So staple it within a foot of the box, and then every 5 feet after that. What about for BX? The rules for BX are a little bit different in that they don't tell us anything. I guess if we're trying to go and save words or something like that. But if I go down to my use inside of here, terminating, radii, and running of cables, it just says armored cables shall be supported between boxes and fittings in accordance with the rule 12.5.10. In other words, I need to do the exact same thing as I did with my Lumix. 12.5.10 is a Lumix rule. They just refer to it inside of there. It would have been better if they just reprinted it, because honestly, it's not that hard. But they decided not to. So anytime that we are running BX, once again, a strap within a foot of the box and every 5 feet after that. There are a few others, because 12.5.10 does not just have these two, rules inside there. It does also talk about that if it's run through holes in joists or studs, it's considered to be supported. If it is going to go and be fished in or anything like that, then, we don't have to support it. And then the last one over here deals with a type of device that's used more on the East Coast, where they kind of just cut in lines the conductors to go and put devices on. We don't use those, so we're not going to worry about it or try to explain it. Okay, moving on from there, let's take a quick look at some of our supporting rules just on our main types of raceways that we will use. EMT that we are going to go and use, we have to go and support it. Shall be installed as a complete system. In other words, you can't just have it like, all of a sudden end off and with no box in the end. Fastened in place within 1 meter of each outlet box, and the spacing between supports has to be in accordance with Rule 12.10.10. So 1 meter from the box is where we have to have our first one, and then 12.10.10 says that for half and 3/4, that's 16 and 21, we need to go every 1.5 meters. If I had larger, it would only need to be every 2 meters. That's going to be for 1 and 1 1/4. If, by the way, you are unsure how to go and figure out what size is what, or you had trouble remembering, at the very front of your code book, there is a table that gives you metric units, so it gives you conversions, so you can convert, different types of things into other types of things, millimeters, circular, inches, things like that. All of that's going to be inside of that. Underneath that, we've got one for conduit tray sizes. 1/2 inch is going to be a 16 millimeter. 3/4 is going to be a 21. If it helps, put those designations above, inside of your code book. You can't have your code book marked up before you're interprovincial, but once you finish your interprovincial before you write before your field safety representative, you absolutely will be allowed to have markups inside of it. Okay, going back into section 12, where we're going to talk a little bit more about my types of raceways. I'm just scrolling to it. Hold tight there for a minute. And liquid tight that we are going to go and have. Liquid tight has to be limited to not more than 1.5 meters that we are going to go and utilize at a time. And then going up a little bit further from that again, rigid and flexible metal conduit. So flexible metal conduit is going to be what we refer to as flex. It's different than liquid tight. The flexible metal conduit is going to be limited to that same length, 1.5 meters, if it's going to be a 3/8 size. That's the number 12, and that's the only place that we get to go and use that. For the rest, if it's going to be full size, we are allowed to go and use longer runs. Let's go to those longer runs over here. Spacing, 1.5 meters. For 21, 2 meters for anything that's going to be larger as well. Nothing, crazy in here. These are just places that you need to know about, inside of your inside of your tables and inside of your code books so that you can find, the correct way to go and install. What about when we are going underground? Where do I find rules? Well, if I'm going to go underground, that is a type of wiring. So I am going to need to take a look at underground sections. I'm going to go back to my beginning of section 12. Section 12, under its general requirements, talks about wiring in different locations. First one's in air handling, that's ducts and plenums. Second one is going to be in underground. Underground cables are going to have a certain amount of cover over top, table 53. We're able to go and subtract that cover out of these two rules over here. We don't have to bury them as deep as long as we provide some alternate forms of protection inside of the trench, etc. Then it talks about that they have to be installed underground so they run adjacent to each other, and that we have to have screened sand or screened earth that is going to be 75 millimeters deep, that is above and below. That's going to be 3 inches of sand above the cable, 3 inches of sand below. Maximum particle size is 4.75 millimeters. In other words, all the dirt or sand has to go and pass through a sieve that has got holes no bigger than that across it. Mechanical protection is provided by how deep we are going to go and bring these things in. Where we do bring them up, we have to go and protect them from mechanical damage either by location, putting them in a place where people can't run into them or stuff, or by using a rigid conduit terminated vertically in the trench and including a bushing or bell end fitting or other acceptable protection at the bottom end from 300 millimeters above the bottom of the trench to at least 2 meters above grade. So if we are going to bring a tech cable that we're running above the earth, what we need to do is we need to take a chunk of rigid conduit. It's supposed to have a bell end on the bottom. That's going to be the side, the female end of the conduit. You're supposed to go and push your cable in through that. They want that flared end on there, so you're not going to scrape the outside conductor. You bring that thing up and through, and that's going to go and provide you with that protection. There are other ones inside of here as well. They talk about, backfill conditions. They talk about if we're burying them into rocks or anything like that. If we're talking about direct burial, we're also allowed to go and install things directly below a concrete slab at grade level. This is new. See a little delta over there? Some of whoever you're working with and stuff, whether it's going to be other apprentices or whether it's going to be foremen or even company owners, they are not aware of this, that we're now allowed to, because you used to not be able to do this. You used to have to dig the sand underneath the slab and bury it into the sand. Now we're allowed to go and place it directly beneath the concrete slab. Just lay it in there, provided that the slab is not less than 4 inches, 100 millimeters. And you also need to go and mark where this thing is going to be. According to Technical Safety BC, marking their locations on as-built prints counts as the marking for these. All right. They give a few more things underneath there for protection. If you go into your book over there, they talk about flat conductor cable, and they talk about, conditions inside of lanes. Look those up. Do the highlights on those ones. Let's move on from the protection. Let's talk about clearance and spacings. Clearance and spacings are going to obviously need to be kept so that we don't have electrical shocks. Now, there's going to be clearances and spacings between buildings, as well as we are going to need to have clearances and spacings between conductors. And then our Canadian Electrical Code is also going to make sure that we're pulled off of anything that produces heat. That's going to be heaters or luminaires themselves as well. If you go into that spacing section inside of your module over there, they talk about air spacing between non-metallic, that's Lumix, and heat sources, ducts, chimneys, things like that. You got to go to 12506. That's going to direct you to those clearances themselves. They talk about cables themselves in diagrams D8 through D11 and clearances that we're going to have off of those. These are ones that we have not looked at yet, but D8 to D11 is going to be insulation. Hold on, let me just go to these. Is going to be the way that I can do direct buried installations. And there's a whole pile of different types of direct buried installations that I can go and do. Spacings underground. As I do that, I'm able to go and get different ampacities out because the earth is going to act as a heat sink. That's stuff we're going to cover once we get into fourth year. Or you should be covering once you get into fourth year. It's a bunch of complicated tables, but they give you spacings and how we are going to go and lay those things out. Class 2 circuits, which are going to be my low power circuits, same with Class 1, are going to need to be spaced as well. We do have rules for those inside of our low power section of the code. Note that it's not low voltage because we can get all the way up to 16 or 600 volts inside of it, but Class 1 and Class 2 are going to be dealing with low power where we don't have a lot of VA. Limited to 100 VA if it's going to be a Class 2. Same with communication cables. We have to keep those cables away from our main NMDs because they are going to go and give us electromagnetic interference. Rules for that are going to be found inside of your section 16. The next couple of things that they lay out inside of your Q1 learning test, color coding and protection, we have gone and covered those over. The table 19, the color coding, we're not going to go and take a look at that. And then there's also another little thing that gets brought up in here about insulation testing and fire stopping. Once again, they don't have a code reference that is going to be part of these. These are just part of your installation. Installation integrity is where we can go and check if a conductor has been damaged. Some types of installations, government installations, hospitals, things like that, are going to have extensive testing that needs to be taken care of so that we know the install is good. People aren't going to die from it or anything like that. Part of that is going to be using what we refer to as a megger. And a megger is simply going to be a massive ohm meter, a mega ohm meter, sometimes called a high pot. What we will do is we will go and connect, we will make sure our conductor itself, so these are my two conductors inside of a 2-conductor cable over there. We won't look at the bond right now. What I can do is I can go and connect one end onto my megger over here, and then I'll connect the other end of my megger to ground, and then I will isolate this end so it's not connected to anything, and then I just turn on the megger. And what the megger does is the megger starts to go and measure, and it starts to look for where the insulation starts to go and weaken. And then it gives us a reading off of that. The longer that the cable is going to be, the longer this test is going to go and take to run because it does, provide a bunch of capacitive charging. You'll cover that in fourth year high voltage. Just be very aware that if you are doing megger readings, you need to discharge your cables after you have meggered everything, and you have to be very careful around that. It does work in the thousands and thousands of volts that we are going to be testing. We are over testing it. This cable over here might be only used for 240 volts, but what I'm going to go and do is I'm going to test it to a couple thousand volts to make sure that if it's good for a couple thousand, I know it's going to check out for this 240 volts. Fire stopping. As apprentices, you are probably quite aware of what fire stopping is. This is where anytime that we've got fire walls, think about condos, those like big concrete walls that are partway up there, anything that pierces that needs to go and be stopped up. You're going to get the big tube of reddish or sometimes black, sticky, tarry type of sealant, and you need to go and place that around anything that has pierced through that. This is not something that is going to be out of our Canadian Electrical Code. This is a requirement of the National Building Code of Canada. What we want to do is just make sure that nothing can go and spread through those. If we have got totally enclosed non-metallic raceways, that's going to be like plastic conduits, PVC conduits, or anything like that. Or if we've got conductors that are passing through, they also have to be rated according to the National Building Code of Canada. We're not allowed to just run Looming says, through from one side to the other. We need to make sure that what we place through those, that it won't burn away and allow that fire to cross through to the other side. All right, That is a very broad tour of the Canadian Electrical Code, sections that should be familiar to you at this point. At this point, you are about 5-ish weeks into second year for this class, so you probably have seen a lot of these sections already or paged through them. But if you haven't yet, these are areas that really, as you work your way to getting that Red Seal certification, you need to get into that code, make sure that you're ready for it, because all of your exams coming up are going to have code that is going to be part of it. Standard level exams and your interprovincial. That's why we prep heavily on the code as well, because theory, people either get it or they don't. Code, anybody should be able to go and look up their code, and they should be able to obviously install everything correctly in the field. And that's the biggest thing with the code. It's there to prevent any sort of safety hazards.